In this video, we present VAC-CNN, a visual analytics system for novice machine learning practitioners to conduct interpretable comparison studies upon multiple CNN models. VAC-CNN consists of three phases: information overview phase, task customization phase, and model explanation and comparison phase. At the information overview phase, users can explore multiple visualizations to get a high-level understanding of the model's performances or inspect the examples of the 5 visual explanation methods. After getting enough information, users can move on to the task customization phase to customize the model comparison tasks. In this phase, Task 1 is the multi-model exploration, and Task 2 is the single model investigation. Through the sidebar, users can select things like image classes, CNN models, and visual explanation methods, etc. After finishing the selection, users can start the third phase of the model explanation and comparison. We will introduce more details related to this phase using one use case scenario. In this use case scenario, we illustrate how to use VAC-CNN to compare behaviors of different CNN models in the animal classification task. After opening up the system, we start by looking over the visualizations of model performances. We find that the ResNet models have a performance boost from ResNet 18 to ResNet 152. We also find that ResNet models often have good performances in the animal root class. By clicking on the model name, we update the pinned model to inspect its class distribution, as well as the examples of the visual explanation methods. From the right view, we can find 2 bar charts presenting the range and mean value of the class accuracy. Since the model performances vary rapidly for the class crayfish within the animal group, we decide to compare model behaviors within this class. After selecting the crayfish at the sidebar, a scatter plot is updated in the right view, presenting each model's performance of this class. Through investigating the scatter plot, we find some models with bad performances, such as AlexNet, whose accuracy on this class is as low as 14%, so we add them to our model comparison list. Then we finish all selections at the sidebar and click the Run button to start the model comparison. When looking at the updated images in the visual explanation view, we notice that the image background of the main object is very complicated for almost every image within this class. This can be a potential reason for the varying model performances. Keep this in mind. We click on the individual images to check the quantitative performance measures and the associated qualitative visual explanations of them. The visual explanation view and the supplemental view are updated according to our selection, showing information to support our comparative study. In the visual explanation view, by sorting the table according to the class accuracy, we find that the size of each model's region of interest has a positive relationship to the model's prediction correctness. AlexNet with the lowest class accuracy only highlights a very small region, while the region highlighted by ResNet 152 is the largest. This means, for this selected image, ResNet 152 has a broader view compared with the other models. Given that most of the images in this class have complicated backgrounds, we conclude that ResNet 152 can achieve better performance than other models in the animal class with such features. In this use case, we demonstrated a multi-model comparison scenario with 5 CNN models. The number of models to compare can be increased to up to 13. Moreover, our system also supports in-depth investigation of a single model, including color intensity histograms as complementary information. Please check out our paper for more details.